Hey guys, today we're going to be doing facial recognition on Python using the OpenCV library. Before we get started on the code, what I wanted to do was actually just execute the script and show you what it is that we're working towards. So I'm in this directory currently. You don't need to worry about most of this for the time being. You just need a file where we're going to write our code. I've called it a.py. We're going to need OpenCV master, which we will download in a moment, and I'll leave a link in the description to it. And then you want to create a resources file, and we're just going to go ahead and go into this resources file, and all I've got in here is a few pictures. I've got all my images from pexels.com, I think they're .com, and I'll leave a link to every image I got, but all I recommend is just download 3 or 4 different images including faces. You want pictures of groups, close-up pictures of people's faces, so it doesn't matter where you get them. We can go. I'm actually going to go through them. So that's one of my faces. This is face 2. Then we've got face 3, which is a group of girls. We've got face 4. This seems to be some kind of staff photo. And then we've got face5.jpg, which is a big group again of colleagues or just a general meeting. And what we're going to see actually is that our software can detect a lot of faces, not all of them though in this case, and there will also be a lot of false positives, which we'll cover. So pause the video, download a few images, and get back to this point. Something worth noting quickly: if you do decide to get your photos from Pexels, let's just choose a random photo. Yeah, let's just grab this. Under free download, there will be different sizes, and some of the original ones are huge, as you can see. So just make sure you download the smallest one, or even smaller if you can. I'm not sure if you're allowed custom size. Alternatively, of course, if you're getting it off Google, it doesn't really matter too much. So hopefully by now you've got some images, you've got them in a resources file, and in a resources folder, and you have an empty file called whatever you want, a.py or facerecognition.py. It doesn't matter too much. So what I'm going to do now is, just so you can see what we're trying to build, I'm just going to go ahead and execute this Python script. So we're just going to call a.py, and what we get here is this is image number 2 that I showed. We've got a blue square around his face, and then we've got 2 smaller green squares around his eyes, and that's what we're essentially going to be doing. There's different images, but we're just going to use this one for now, and then I'll look at all of the images as we work through our code towards the end. Something else that we should quickly note, or that I want to just explain to you, is that when we use coordinates with images, we start in the top left corner usually. So the point 0, 0 is represented by here. And also later on, when we're going to be making subplot, not a plot, but sub-images almost, this rectangle here, this is where the xy is defined, this is where its xy is defined, this is where this rectangle's xy is defined, and so on. And to draw a rectangle, you would say xy, and you'd have x plus the width would give you this point, and you'd have y plus the height would give you this point. So this is 0, 0, so we start on the y-axis, we go from 0 to its biggest number, and on the x values we go 0 to its largest, to the image width. So 0 to image height, and 0 to image width. So you need to know that. So there's 2 things we need to do before we actually get started programming. The first thing, of course, is we need to install OpenCV. And then the second thing is we need to get the XML files that we're going to be using, the Haar-cascades they're called, that we're going to be using to recognize our faces and our eyes. So let's go ahead and do that. So to install OpenCV is really simple. On Linux we just need to do sudo apt install, and then I think it's Python 3 OpenCV like this. Put in your password, of course. I'm not sure if I did that correctly. Then I've already got it installed, so nothing's going to change for me. It might take a little bit longer for you. So the next thing we need is these XML files, which essentially hold the data for us. So that we're using Haar-cascades, and I'll explain more about them as we go on. And if I'll leave a link in the description, but it's essentially github.com/opencv/opencv, and if we go into data, and then we go to these Haar-cascades, then we want this XML file, this Haarcascade _i XML file, and we want this frontal face default XML file. So if you want now, you can just download these two specific XML files. It's probably easier to just clone or download this whole the whole OpenCV project into the directory you're working in. If we go back to our terminal and then we list everything, and then all you want to do is just extract it all, and we'll have OpenCV master. So once we have that, then we've got some images, we've got OpenCV installed, and we've got the Cascade files, for Cascade XML files that we're going to be using to actually do some facial recognition. So we can start now by actually opening our Python file. I'm using Emacs. It doesn't matter whether you're using Sublime or the Python IDE, idle, sorry it's called. Just open a text editor and let's start writing some code. So the first thing we need to do is import OpenCV, and we do that by importing it as CV2. And the best thing to really do is just to quickly execute your Python script to make sure that you've actually installed it correctly. If you have, then you're not going to get any error messages. So we've got that on our system, and it can see it. The next thing we're going to do is, as I said before, we're going to grab those two XML files. Now I don't want to type that out, so I'm just going to copy and paste it in from my other monitor. And what we essentially have is two cascades. We've got our eye cascade and our face cascade, and we import those. We bring them in by using this cascade classifier method from CV2, and all we have to do is navigate to our where those XML files are, if you remember. So I have OpenCV master, then we went into data, into Haarcascades, and that's where our XML files is. If you just download the XML files, and you have them in your immediate directory, then you can just skip out all of this, of course, and then just have the XML file in this file path. So that's what we need. Next, we're going to so actually I'll leave a little comment there, just for. So that's our Haarcascades. I think I've spelled that correctly. And there, Haarcascade XML files, really. When we use a Haarcascade filter, it's already been trained, so all we're getting is a bunch of numbers, and when we open an image, when we try and implement the algorithm on our image, it's using its pre-trained data to actually try and classify our image. So they're just numbers, I think. You can actually open it up and have a look in there. I think they're just loads of matrices, probably. So next we want our image. So image, and we're going to store that in a like this. It's going to hold our image object, and we're going to use cv2.imread, which actually allows us to just go ahead and grab our image. Remember, our images are all in our resources folder, so we can just do face2.jpg was the name of my file. Make sure you actually use a correct file name. So again, we're probably at a point where we just quickly want to check that we've done everything correctly. So no errors. So it's found the file path, and we've got OpenCV, and we've got our image. So everything is going well so far. Yeah, always be careful with file paths. Right, next what we want to do is we want to convert our image to Grayscale, and the reason we want to do that is mainly because we get a lot of information from Grayscale. So this isn't a Grayscale video, but Grayscale gives us brightness values instead of color values, and we essentially turn our 3 RGB values, so red, green and blue, into one Grayscale value. Now I'm not going to go over how we do that, but it's pretty simple. We just give each color a weighting that then add up to make the number 1. Anyway, so also we'll cut our processing down by 3, really, because rather than processing red, green and blue, we're just processing our one gray value. So we do that. Let's Grayscale image, And when we're trying to do facial recognition, no, let's do grey. It's actually, you don't necessarily need the colour, because brightness, like the darkness around the eyes, can kind of tell you that there's eyes there, and there's lots of different indicators. You don't necessarily need the colour. So next we're going to do convert to colour. Firstly we need cv2.cvt colour, and then inside here we're going to hold our image object. So we're basically converting our image to grayscale, and we do that with cv2.color, and it's BGR rather than RGB to grey. Now there's actually loads of different conversions that OpenCV allows you to do. I don't remember what the exact number is, but it's much higher than you'd think. So we've converted our image now to a grayscale image, and that's going to be it for the moment. Actually no, we're going to do one more thing. Not in this video, just in this segment. So we're going to create a list now, and this list is going to hold our faces. This is really cool, so we're just going to call it faces, and let's just write the code out quickly. So we're going to have face, we're using our face cascade now, and then this is going to have a detect multi scale, and remember to use the capital M there and the capital S, and this is going to hold 3 parameters. So here we could either put image or grey, but as we discussed, we're going to be putting grey just because we don't need it to be image. It's just unnecessary processing for now. Then we're going to give it 2 parameters, which we're going to discuss in just in a moment. It's going to be 1.05 and 6. So it's probably better actually to quickly represent those as variables. So what we have is a scale factor, and this scale factor is 1.05. Again, we're going to discuss that in a minute. And then this one's going to be min neighbors, and that's going to be 6. And let's pop those values in here. So scale factor and min neighbors, like this. And what this line of code right now is doing, before we discuss what scale factor min neighbors is it's going to create a list of faces. So when we open up an image with this, this is our facial recognition, by the way. This is going to do it for us. And when we have an image of just one face, then this value here will just hold 4 values, and it's going to be our x and y coordinates that we talked about earlier, and then the height and the width. Width and the height in order. So this will return a list of 4 values if there's one image. Now if there's multiple images, it's going to return a list of lists, and each list then will contain those 4 values. So it looks something like this. So we have a list, and then our first list is going to be our first face that we detect. So it's going to be x, y, and then it's going to be width and height. And of course, if we have lots of faces, then we're going to have lots of these. So we'll have x1, y1, and w1, and h1, and then we'll have loads of these. So that's what this variable is. Actually, we could probably, let's go ahead and print this. There shouldn't be any errors. We should be able to do that. So, sorry, we didn't actually print them. My mistake. So let's print faces. So we've detected a face, and it's at this position. It's pretty simple and really neat, and if there was lots of faces, then we'd have lots of these values. That's all I want to say. So let's go back to our Python script now. We don't need to print the faces, and this is our facial recognition, by the way. This is basically, as you see, the fact that we've got a value means a face has been detected, right? And it's given us the position. So at this point, all we would need to do is actually draw a rectangle around every point that we find. We're going to get on with that in just a moment. Before that, let's just quickly describe a scale factor and minimum number of neighbors. Now, if you remember at the beginning of the video, we had a picture and there was a blue line around the face and 2 green lines around, 2 rectangles, sorry, or square, in fact, and 2 green squares around the eyes. And what we're doing with that, let's just talk about the face actually, because we're just doing face right now. This is just a face detection, not eye detection. when we load in the Haar-cascade XML file, all that is a file of data, essentially, and it's basically saying this data set will allow you to try and find faces in images. All that data has come from certain sized images. So you want a certain scale of image in order to detect a face in it. What if you input now a huge image, 10,000 by 10,000 pixels, and it's the whole face fits on that image? Now, how would you actually recognize a face in that if the data has never seen an image that big? Well, you have to scale it down. And what we do is we scale it down on multiple iterations, because we don't know how big the image is to begin with. We try and make it smaller and smaller and smaller and smaller, and we just keep running the same process on it until the program actually detects a face on it. So that's how we do that. And the actual factor here, this is 5%, right? So the smaller the percentage is, so right now we're making the image smaller by 5% on every loop. If we made that a larger number, then it would skip a lot of steps. So by having this as a small number, we're more likely to actually find a face, or we're more likely to put the image at a size where the data was trained on, if you will, because we're going in much smaller increments or decrements. And then the min neighbors is the number of times we have to detect a face before we accept that it's a face. So hopefully I explained that well. If I didn't, then I've actually got a blog post coming out on this, so check out my website, check out the blog post, and it will talk about it in more detail. Something else I also quickly wanted to note was that the way this, and it will be explained in the blog post again, the way these cascade classifiers work is they consist of many classifiers, and we break the image into segments, small segments, and then we check those small segments with smaller classifiers that we are seem to indicate that there might be a face there. And if the indicators are not there, then we get rid of that window. We say there's not a face there, and we move on to the next window. And there's a bunch of small classifiers, and you can imagine we have a stage 1 of classifiers, like look for this, look for this, look for this, and if we find those things, there might be a face there. Then you have a second stage of classifiers all looking for different stuff, and then a third stage of classifiers. That's where the cascade comes from, the term cascade, because there's a cascade, like a waterfall of different small classifiers, and eventually we're left with this really high probability that there is a face there, if it continues to go all the way down. Anyway, hopefully you get that. We're now going to go on to the next stage. So we're going to say, remember what I said faces looks like, so we're going to say for x, y, width and height in faces, our list. So we just want to get all of those parameters. Well, we want to create an image which now has a rectangle. So we're going to redefine image, and we're going to say cv2 rectangle, and we want our image, firstly, that's the colored image, not the grey image, because at the end we want to display the colored image, and we want x, y. Then we need to tell it where we want to draw it, so it's going to be x plus the width and y plus the height, like we explained at the beginning. And then remember, although we usually say RGB, in OpenCV they actually define it as BGR, so we've got blue, green, red. So if we want a blue line like we had, we want 255 here, then green is 0 and red is 0, and then we want a 2. Now if you don't like spaces, just get rid of them. 2 is just our thickness, by the way. So we've got our image now, and it's a rectangle, so we're saying for each face we're going to draw a rectangle around it. But remember, we also want to detect eyes, so we're going to go on to that now. So we could create another for loop where we look for eyes in exactly the same way, but we already know that if there's a face, then the eyes are going to be within the face, which is why the best thing to do is to have another for loop within here where we look for the eyes and essentially within the face box, which makes a lot more sense. So we're going to define two variables first that we need to define, and they're going to be called, that's the region of interest for our grey image, and this is just a splice really, And what we're just saying is we want this to hold all the, hang on, let me just write it out quickly. It's y colon y plus h, and then we want x colon x plus w, and then we're going to do the same thing for our image, which is our colored image, and it's a region of interest. That's what the ROI stands for, and it's going to be exactly the same. I probably should have copied and pasted it, but I didn't. What does that want to be? Height, and then x colon x plus w. And essentially what this is doing is we're redefining the window now. So we're now saying our image is no longer this whole image. Instead, the image is just this segment where the face is, right? So our y values are going to be, our x and y values are where we first spot is the coordinate of our face, and then the width and the height. So we're now looking for all of the elements within our squares. Hopefully that makes sense. Within our faces. And we've got one for color and one for gray. So the grey one is going to be for processing, and then the image one is going to be for displaying. So that's why we've got two. So now we need to do this for loop, and we're going to say for the same as before, but this time we're going to have an E in front of everything. So I'll actually put those in a second. So that's going to be E, and that stands for eyes. Let's get rid of the gaps. In eyes this time, we actually need to define eyes like we did with our faces here. So we have our face cascade here. So here we're going to have our eyes, which is going to be our eye cascade. So I underscore cascade dot detect multi-scale. And something I didn't actually cover earlier, which we will in just a second, is, wait, what do we want in here? We want our grey one. If we go back to our browser and we go to our Cascade classification, I didn't actually specify that these two parameters that we defined, they are necessary, so they will actually have default values, right? We can never leave them blank, but we don't have to define them. If we just leave them blank, our scale factor is 1.1 and our minimum neighbors is 3. So I'm going to we can just leave those blank for now because they have actually got values that are 1.1 and 3. And hopefully it'll be much easier to actually detect eyes once we have a face. So it should work really well. So in eyes, and what we need to do now is we want to draw the rectangles just as before. So we can just actually grab that like this, and I think that's all we need to do, except we need to change this. And the reason, so what we're doing here, so you don't get confused, is the reason we had to have a color one is because we've changed our reference system, right? So, pardon me, coronavirus. What we've got is, so initially we had the whole image, but what we did here, we found our face, so we've created this new image, which is just where the box where the face is. So it's going to have a different reference system, if you will. At location 0, 0, we will now just have at whatever's at XY, if you will, in the position. So just to keep everything consistent, when we display it at the end, we need to make sure that when we're drawing the rectangle, we're actually using the same reference system as the Cascade is using, if you will. So these two reference systems are now aligned. Here you could just put image, right? But then they would be like by 0, 0 up in the top left corner. But I don't want to confuse you. But that's everything. So we found our face, and within our eyes, within the faces, we found our eyes, hopefully. So let's see if that works. So all we need to do, all that's left now is to do imshow, and it's going to be our img. We're going to show our image. Remember, we're displaying everything on the image, and this is just going to essentially superimpose in front of the other image, but in the same spot, so it won't be detectable. CV2, then we need to, I think by default it will just actually close straight away. So if you open it, it will just close straight away and you'll never actually get to see the image. So you want to do cvt.wait key, which is just waiting for you to input any value into your keyboard. And then once we've done that, then we want to destroy all windows like this. So this code is just straight from the OpenCV documentation. So hopefully you've understood all of that, and let's see how our program does. Let's go to our terminal, execute our Python script. Let's see, Roy color is not defined. That's because I called it Roy im. Hopefully that's the only error we've got. What are we displaying? This is because we don't want to do this. Yeah, I was right that I did superimpose it, but we just want to do this in the same way. We've already got our image, we just want to draw on the rectangle, so let's see if this works. So, slight error there. The other obvious mistake we've made is, whoops, let's do this, is here we've used X and Y, but we really need to use EX and EY, and EX and EW, EY and EH. Let's see if that fixes anything. So we're still using blue because we copied and pasted it. So the last little thing that we just need to do to get what we had before is change this to the following. Remember, it's BGA. So there you go, that's the initial image we had, and what we can do now is we can play around with the different parameters and the different images. So let's do that. So we've just been using that one image for now. And what we're going to do now is we're going to switch up the images. So let's start with face 1. And what we're going to see is that by actually choosing these different values, we're fitting different images. Because this is essentially what we're doing, right? We're choosing a couple of values that give us the best results for that image. It's kind of every time we run it, we're overfitting for that particular image. But I'm not going to talk about that. Let's just actually run the script. So we've changed to image 1 now. And as you can see, with our current scale factor, and the current min neighbors, we've actually detected 2 faces and 3 eyes, which is pretty funny. But that's what we've done. So for now, let's not tweak the parameters. We can tweak the well, actually we could tweak the parameter. For example, we could change this to 1.3 and this to 3. Actually, that's probably too big. Let's make this yeah, let's see what happens when we do 1.4 and 3, and we actually get a perfect match there, which is quite funny. I wasn't expecting that, because remember what I said before with the scale. Again, read the blog post though, because blog post is hopefully going to be much more detailed and clear up any misconceptions or things I've explained badly. So 1.4, we're taking that image and we're reducing it by 40% and then running everything again. Then we're reducing it by 40% again. And the min neighbors is now, this time we've had to only detect 3. Yeah, so you can actually, something I wanted to show you is if I make this like 1.01, so it's going to take a lot longer to execute the script, and notice how many faces we've detected and eyes, and then this is 3, but imagine I change this to 1. Still only the same amount, but so that's going to be the maximum. So let's change that back to 6 and 1.05 again and switch up our image. So we've had face 1, we've had face 2, let's do face 3. That might be a group of faces, I don't remember. So here we've got a group of faces, and we've detected 4 faces, just not in the correct places. And we've also detected 4 eyes, but only this woman here in the middle, or person, I should say, you know, we've identified correctly, except the teeth actually, that's not an eyeball. So again, we can play with the parameters, but let's not do that. Let's choose a more interesting image. Let's go to image 4. That looked quite promising. That was the office. So here we've detected most faces, not all of them. We're missing this face. We've also detected a face up here, and we've detected a face here and here. So it's not perfect, but I will tweak the parameters there. So 6, we actually still had too many, so I think we want to make this worse, essentially. So let's make this 1.3 like we did before, and say 4. And there you go, that's a pretty good attempt. I'm not really sure why we can't detect that this is a face, but we can't. I played around with it before and I was never able to get that face. So if you use the same image and you find some parameters that actually detect that face, then tell me, I'd like to know. I guess you could also run a for loop or something, test all of them. Phase 5 now. This is probably the most interesting one. This is a huge room of people, so here we actually want a smaller scale factor, I think. This is going to give us, in fact, maybe even 1, right? And let's say 6. This might take a minute to execute, so let's wait patiently. So that's way too many faces, but we have actually detected almost every face, but we've also detected a lot of things that aren't faces. So let's just make that 1.05, so 5%, see what we get, and see how much faster that was, just going from 5% to 1%. Again, a lot of false positives. But anyway, I'm kind of just rambling on now, looking at different faces, but hopefully you've understood what this is all about and what parameters you can actually control. Remember, we didn't actually play around with these values, the eyes, so where is it? Here. You're still able to have a couple of parameters. We can use a scale factor and neighbors in the eyes too, so play around with that. And hopefully that was useful, you learnt something. Again, if you want to learn, if there's anything you haven't understood, then check out my website. I've got a blog post on this. Yeah, and thank you for watching.